Greetings and welcome to InfoTrend. Today we're excited to introduce our newly announced GSx parallel file storage system. Today's main topics are parallel file system, PFS for short, overview. We will discuss what makes PFS such an effective and important solution. Next is going to be GSx Introduction itself. We will take a look at our new product and its capabilities, as well as the type of networks that are used in our system. Next, feature highlights, a look into the advanced features offered by the GSx family. And lastly, applications, where we will discuss a couple of real-world use cases and scenarios where the GSx series excels. So let's start with a parallel file system itself. It is a specialized technology for storing and managing files designed to provide high performance and simultaneous access to data across multiple nodes in a cluster. Key characteristics of parallel file systems include distributed data storage. Data is stored across multiple nodes, allowing parallel processing of said data. Next is high throughput, which is self-explanatory. And lastly, distributed access, where multiple servers can access files simultaneously. The market for parallel file systems has significantly grown over the past 5 years, primarily driven by increasing data volumes and the need for efficient storage and data processing. In high-performance computing, HPC for short, data analytics, and artificial intelligence, AI, parallel file systems are basically a must. Based on everything we've discussed so far, we are proud to present our own PFS system, EonStor GSx. With multiple GSx appliances combined in the cluster, enterprises can achieve faster data processing through concurrent I/O paths. Very important note, GSx simplifies IT architecture by completely eliminating the need for an additional parallel file system software and a separate metadata server. Metadata server is integrated in one of the nodes. GSx was created mainly for high-performance computing and artificial intelligence applications. Hardware-wise, GSx holds the similar line to our main GS family. As you can see, we have both all-flash U.2 models with the GSx 4024U and GSx 5024UE, as well as high-density models with GSx 4090C and 4060C. GSx utilizes algorithms to stripe data across multiple storage units. This ensures efficient data distribution and resource utilization across the storage cluster. Parallel file access enables simultaneous data access across multiple GSx nodes, which results in a higher performance compared to regular storage systems. Finally, as already mentioned, GSx has an integrated metadata server, where one of the storage appliances will also be responsible for managing the metadata for the entire cluster. A small note here, it is recommended to reserve 2 data channels per controller on this metadata node for the metadata server network. Now let's take a look at a cluster networking. There are 3 types of network in this cluster. First, metadata server network, MDS for short. Host will connect to the metadata server located on one of the storage appliances, in this example, appliance 1, to identify data location before accessing this data. Second, data network itself. Through this network, our hosts will access the data stored on our storage. And finally, the management network, where the administrator can manage the cluster through our web UI. Here we can see the supported interfaces for MDS and data networks, respectively. Metadata server network operates on file level, while the data network is using block level access. Now, for the performance aspect, a single GSx 5024U appliance delivers up to 43 gigabytes per second of read and 17 gigabytes per second of write throughput. When multiple GSx appliances are clustered together, the performance scales almost linearly, delivering even higher throughput. The entire GSx cluster system can achieve an almost 10x performance increase. Important to also discuss the expansion aspect itself. Our solution allows organizations to start with a single GSx appliance and scale out to incorporate up to 10 GSx appliances as a one storage cluster. This scale-out architecture enables linear expansion of both performance and capacity. In addition to scale-out expansion, our high-density GSx solutions support JBOD expansion as well. Additionally, to simplify access and management, our solution supports a single namespace architecture. Next, for the deployment process. I will not bore you today with the step-by-step deployment itself, so let's just highlight a couple of main things. During the deployment process, we will be able to set up both metadata server and all of I/O nodes as well. This approach simplifies the setup process, eliminating the need for a separate server installation, managing several softwares, etc., etc. Besides that, the whole process will be accompanied by our user-friendly installation wizards that will guide you through the setup process step by step. Now, after the deployment, the whole management will be done through Eon One Web UI, which might be already familiar to you. As for the data protection, let's just have a quick glance. RAID 0, 1, 5, 6, 10, 50, and 60 are all supported and easy to set up. So whatever the application or user requirements are, we are sure that it will be easy to configure the system just right, based on your personal requirements and needs. Besides that, we have a built-in media scan, which helps the firmware to identify bad blocks or sectors on the drives. In the event of detected errors, data restoration mechanisms are triggered, and they restore the affected data to healthy blocks, ensuring data integrity. Another point I want to mention is that our system prevents the SSD drives from running out of their lifespan at the same time, which could lead to potential data loss. As you know, SSDs have a limited number of writes to them, and our firmware works around it, making sure that 2 or more drives will not run out of their write limit at the same time. Finally, the monitoring capabilities. You will be able to see the remaining life of your drives, its temperature, total bytes written, indicated as endurance, disk writes per day, and other characteristics as well. Now for the integration of GSx storage into an existing environment. We have created a special file agent that can be installed on Windows and Linux currently, which will help with all the metadata processing, as well as grant access to the file sharing through CIFS or Samba protocol, which is also used across all existing OSs. Besides that, we have flexibility in choosing between iSCSI and Fiber Channel for data access itself. Fiber Channel offers high-speed, dedicated connectivity suitable for mission-critical applications, while iSCSI provides cost-effective and scalable network access over IPs. GSx was created to address the increasing demands of high-performance computing and artificial intelligence applications. So let's take a look at a couple of actual use cases now. Case number 1, HPC. A research institute employs HPC for conducting a huge variety of scientific surveys, and they will need a high-performance and high-capacity storage for their work. Configuration that we've provided looks as follows. 5 pieces of GSx 1490C, 450 20 terabyte HDDs, and 20 7.68 terabytes U.2 NVMe SSDs. And besides that, the network interfaces of 100 gig. GSx 1490C system by itself provides exceptional throughput, and we are able to get even more out of it after joining 5 of them in a cluster. With their raw capacity exceeding 9 petabytes, the cluster offers enough space to store all the process data for the client. Besides that, having 4 U.2 NVMe drives in each system dedicated exclusively to caching, we are able to enhance the system performance and responsiveness even further. Finally, GSx offers an integrated solution that eliminates the need for additional metadata server. This simplifies deployment and management processes, reducing complexity and administrative overhead. Case number 2, AI. A company requires a storage solution for their AI training, necessitating high throughput for accessing massive training datasets. They seek a storage solution that can deliver up to 150 gigabytes per second of read and 50 gigabytes per second of write throughput to support AI model training effectively. Configuration that we've provided for this case is 10 pieces of GSx 4024U with a total of 240 15 terabyte U.2 NVMe SSDs installed. Network interface in this case was also 100 gig. Our all-flash storage is able to provide exceptional read and write throughput, meeting the demanding requirements for accessing and processing large AI training datasets efficiently. With each GSx 4024U appliance offering over 36 terabytes of raw capacity and a total of 10 appliances deployed, this solution provides enough space for the user to accommodate the best amounts of training data required for AI model development. And once again, GSx offers an integrated solution that eliminates the need for additional metadata server, simplifying deployment and management processes. Now let's dive into the high-performance storage demo. In this demo, we used 3 GSx 5024 URE units to deliver over 120 gigs per second of combined read throughput. 8 servers are simultaneously reading data from GSx cluster to measure the file throughput under real usage conditions. Now let's go to our GSx cluster and run read tests first, paying attention to the transmit section of our dashboard. Here we are able to achieve more than 120 gigs per second of total read throughput using 3 GSx units. Finally, we are starting our write performance test, and as you can see in the receive section colored in orange, we are reaching 52 gigs per second of write throughput with the same setup. Thank you very much for watching today's video. Please feel free to scan the QR code on your screen to go directly to our website and check out our new products. We will be waiting for your feedback.